Welcome to qnawire.
So in this case, you have a simple system like the Earth Moon system here, um, and you know the separation distance, which is 3.84 times 10 to the 8th, so that's R, and they want you to find the center of mass of this system here. So you know the mass of the Earth, it was given like 6.04 times 10 to 24. You know the mass of the moon, which is 7.35 times 10 to 22 kilograms. So this is just a matter of using the center of mass formula that says the radius of the center of mass, or essentially the location of the center of mass, is equal to 1 over the total of all the masses in the system, and then you sum the product of the masses and their distance from a reference here. So in this case, you have two body systems. So this summation just becomes the sum of two masses multiplied by their radii. So the total mass is just going to be 1 over mass of the moon plus the mass of the Earth here. And then you multiply that by the mass is times the radius. So if you use this as a reference, notice that the mass of the Earth and radius of the Earth would just be 0, because the distance from the center of mass that this is 0. So yeah, this is the distance from the center of mass with the reference. So in this case, that would be 0 for the Earth and R for the system. So this is now the mass of the moon times R, which is this distance here. So if you now put in the numbers that were given for the problem, you see that your final position for the center of mass is 4.67 times 10 to the 6 meters in this case. So again, we now have only one term because the distance of one of the masses from our supposed center of mass location is just 0, because we're using this as a reference. So you notice now that this is going to be somewhere in here, because it is less than half the radius. So it's going to be closer to the Earth than it is to the moon.